It took years, but finally the next big thing can change humankind. In the early 2000s, two physicists at the University of Manchester came across a sensational discovery. In one of their Friday night experiments, they isolated an entirely new substance, almost as a joke. It was a material with unique properties, the thinnest and simultaneously the strongest known to science. It was almost entirely transparent, and at the same time so dense as to even prevent the passage of helium, the smallest gaseous atom. It was probably the most extraordinary substance ever discovered, a thin, atom-thick sheet of carbon possessing remarkable properties, graphene. To Andrei Geim and Konstantin Novoselov, that discovery, made while playing with adhesive tape, earned them the Nobel Prize. Yet, since 2004, the expectations of seeing its application in the real world have remained nothing but expectations. For nearly 20 years, graphene has not moved from the status of it will revolutionize the world in the future. The laboratory methods to obtain graphene were inapplicable for scale production. And the cost of producing it flawlessly in significant volumes made its price unaffordable for any industry. But the research just needed more time. And how much became clear at the beginning of the year, when the GAC Group announced mass production of electric vehicles with graphene batteries starting in September. The Ion 5 will be the first vehicle equipped with this technology. The first to be able to recharge from 0 to 80% in 8 minutes. And the first to have an autonomy of 1,000 kilometers, 621 miles, almost 2 times the range of a Tesla Model 3. Long story short, that moment awaited for 17 years has finally arrived. Graphene has officially begun its revolution, and electric mobility will be the first sector to be overwhelmed. A radical innovation. Since its inception, graphene has been paired with a wide range of uses and potential innovations: faster computer chips, super-efficient solar cells, and of course, super batteries. Medicine, electronics, light processing, energy, and the environment will be just a few of the industries that will benefit enormously from its adoption. Graphene will revolutionize today's water purification technologies, innovate the approach to building construction, and even represent a new solution to clean up nuclear waste. Of all its possible applications, however, what particularly surprised was its ability to store electricity. A sheet of graphene the size of a soccer field would weigh only a few grams, could be compacted into an AA battery, and would harvest more energy than any other battery with the same volume. In addition, graphene solves the two crucial problems with lithium batteries: a tendency to deform once discharged and poor electricity conduction. Graphene is highly conductive, retains its shape, makes the battery last longer, and allows for faster charging while managing a more capable electrical charge. Lithium batteries implemented in graphene can recharge faster, as well as dissipate more heat. And this has significant implications not only on electric mobility. Electronic devices take longer to overheat. Appliances serve families more efficiently, and cars can recharge faster. Finally, graphene will bring innovations and properties to future generations of batteries that are unthinkable to achieve with modern technologies, such as 1. Flexibility. Bending current batteries means compromising integrity and functionality. Instead, graphene can adapt to deformations without losing its properties. Something that makes graphene batteries very attractive, for instance, for the realization of folding electronic devices, such as smartphones and tablets. 2. Stretchability. Graphene can meet the needs of emerging stretchable electronics, resulting in devices that can deform without altering functionality and reliability. Shortened graphene, for example, has been used to produce supercapacitors that can stretch 8 times their length. 3. Wearability. Graphene opens up new scenarios for wearable devices. It can be easily adapted and assembled into microfibers and woven into fabrics using conventional weaving technology. As early as 2011, the first textile-based graphene batteries were obtained by coating cotton fabrics with graphene. 4. Fast charging. Lithium-ion batteries suffer from long recharge times, in the view of hours, when instead consumers are looking for something that can recharge in minutes, if not seconds. To this end, graphene can enhance the capacity of lithium-ion batteries and improve their charging speed. 5. Transparency. With 97% transparency, graphene will contribute to advances in transparent electronics, making fully transparent displays possible and more efficient. 6. Longer lasting. Last but not least, graphene will introduce greater storage capacity and a longer and better life cycle, enabling ranges for electric vehicles and run times for electronic devices unattainable with current batteries. Probably too radical too. When GAC Group claimed to have developed a scalable manufacturing system for graphene batteries in January, many thought it was a bluff. Several experts argued that graphene batteries were still years away and that the technology was not yet mature. Others argued that it was possible to produce splendid prototypes, but not feasible on a large scale, especially for a car manufacturer. But despite all the misgivings, GAC Group proved its point early on during its Technology Day held in July. The Chinese manufacturer has also informed the battery has already passed the most rigorous tests, such as battery shooting test, and that it has already left the laboratories ready to enter the real world. For the time being, nobody outside the company knows the type of graphene used, much less the manufacturing process. What is known is that GAC Group has solved the graphene price complication by reducing its cost to 1/10 of normal. But as one problem is solved, another one arises. Providing the promised charging times requires ultra-high power stations of more than 600 kilowatts. GAC Group will build more than 100 of them in 2021, but the risk is that such installations will send the power grid into a tailspin. Experts and graphene startup owners had already pointed out the problem last year, a few months before GAC Group made its plans public in January. The power grid can barely even handle what we have right now, at least when we talk about the Bay Area. It's just something I can't really see happening just because it's just so much power, Samuel Gong, CEO of a startup focused on graphene, told Futurism. It's not just building a nuclear plant and saying we have the power. It's also the power delivery, whether the wiring of the city can even handle that surge in power. In other words, future ultra-fast charging stations will therefore need buffers with static storage. But in this regard, there are still many technologies under study. Bottom line. The hype around graphene has often been motivated by the need for scientists to spark interest in their work. But finally, all the expectations towards this material are materializing into something palpable. If the IonV demonstration at the Technology Day finds further confirmation once industrial production begins, we would be at the beginning of an epochal revolution for the entire world of mobility, of all technology and materials. In the future, graphene will be applied to almost everything. But for now, a car cheap enough for the masses to support this technology is a decisive option to abandon fossil fuels.